Hello, and welcome to project number 5 in our Intro to C Programming. Let's see here. Quickly, let's go over the goal for this one. Given n numbers from the user, n is also user-defined, we're going to sort them and print the sorted list. So, this is a bit more complicated than ones we've done previously. I know that in one of the earlier projects, I used a kind of abbreviated sorting algorithm for just an array of 3 numbers, but this time we're going to be sorting any number of numbers. So we're going to have to deal with that. We're not going to be using any complicated sorting algorithms. It's going to operate very similarly to the one we used last time, but I'm going to be going into more detail. The name of that algorithm is called the bubble sort. It's named so because the greater values will bubble up to the top. They'll just kind of float there to the end of the array. So, steps, pretty similar to usual. Get processor input, pass the array to the sorting function, so we're going to be breaking off into a function. Sorting function will return the array sorted in place, so we're not going to get a new array, it's just going to be the same array as last time, just sorted now. And then we're going to output the sorted list to the screen. So, real quick, we can predict that we're going to need the sorting function. And I want to have a helper function that will print the sorted list out to the screen. So let's do that right now. Let's see. The sorting function is going to be a void bubble sort. Takes an int pointer array, int count, and the array printing is going to be void print array int star array int count. That's not what I wanted to do. My apologies. This is the source code from the last one. I accidentally closed the project. Okay, here we go. We're back. Let's get to work here. So first thing we're going to need to do is we're going to need to process our input. I'll explain that sorting algorithm as best I can when we get to it. So, printf, how many numbers do you want to sort? Char buffer 4. Same as usual, I'm going to be using fgetS and a2i. So, standard lib.h. This is for 2i. Cool. I'm kind of going a little quicker here because we've done this in basically every project so far. So I am trying not to waste your time here. FgetS buffer 64 characters from standard in. Int num elements equals 0. Num elements to I buffer. Cool. There is a bit of a caveat here. If we get 0, or if we get something we don't recognize for the array size, then we're gonna have a problem. We can handle this in one of 2 ways. We can either repeatedly ask the user for input, or we can print an error message and stop the program. This time I'm going to print the error message and stop the program. So if num elements equals 0, printf cannot have an array with 0 elements. New line, return -1. I'm returning -1 instead of 0 to indicate that something has gone wrong. This is just a convention with main. Similarly, return 0 is convention that means everything went according to plan. Part of this is because of the Unix and Linux philosophy. We've seen with GCC that if GCC doesn't output anything, it means it compiled without issue. Similarly, other programs in that kind of space follow the same philosophy, and if they output anything, it means something has gone wrong. We're going to follow the same convention here. So, we don't need an else here because if num elements is 0, we're going to return -1 and the program will end right there. So what next? Well, now we need an int array with however many elements num elements is. So this is a variable sized array. Or more accurately, it is an array that has as many spaces as this variable evaluates to. You can't change the size of the array, you can just declare it differently. So now, we can't initialize this because the C runtime won't let us do that. So now what we have to do is we need to get all of the numbers from the user. So we're going to do that. We're going to use a for loop, for I equals 0. I want to put a few blank lines here so I can put this in the center of the screen where I can actually see it and it's not blocked by my microphone. So for int I equals 0, I less than num elements plus I. So what this will do is this will run this loop num elements times. We've seen for loops before. Hopefully you have played around with them a bit. Yeah, I don't see a strong need to go further into them here. Don't want to repeat myself too much. These videos get pretty long as it is because you're seeing my live thought process as I do this. So, I equals 0, I less than num elements plus I. Cool. Printf. So this time we want to prompt the user for input. We want to do it in a kind of clean way. I have an idea for this. What we're going to do is we're going to give printf a number, and then a colon, and then we're not going to have a new line character. Instead, what's going to happen is the user will put the number in on that same line. And so what this is going to do is this is going to count first element, second element, third element, fourth element, and so forth. So, it's 1 because we want to start, we want to follow human counting conventions and not computer counting conventions. That was loud. And now we're going to get s, buffer 64, standard in, int value equals 0. No, a2i will return 0 if it doesn't recognize it. So what I can do is I can skip a step here and say array sub I equals a2i buffer. That will work just fine. And so this will run once for every element, and once it does that, the array will be full, and we can pass it off to the bubble sort function. So here, bubble sort array num elements. That is a colon and not a semicolon. There we go. Fix that. And now is a decent time to implement the bubble sort function. Actually, I lied. I can just call print array here. now we're done with main. Now everything that we need from main has been accomplished. Cool. Now we can start properly defining these functions. So get their function signatures, copy them, go down here, and put those down. Now, so bubble sort. Let me draw a diagram as best I can here. Bubble sort will take in an array of unsorted values. What it's going to do is it is going to look at one value at a time. So let's put a star there. And let me double check. I've got the algorithm itself on my second monitor here, so I can double check my work. Yes. So what it's going to do is it is going to look at one value at a time, and then for every other value, it's going to see if it needs to swap the position of those two. So, for example, what it's going to do is we're going to start looking at this 4, then we're going to check the 7. 4 is less than 7, so there's no need to swap them. 4 is less than 9, no need to swap them. 4 is greater than 1, we do need to swap these. So we'll swap this, and then this. We're still looking at this position, though. So we're not looking at the 4 anymore, now we're looking at the 1 that we just put here. 1 is less than 2, stays. 1 is less than 3, stays. This second element here will provide a better example of just how many swaps can go on. So now we're looking at the 7. 9 is less than 7, this stays. 7 is greater than 4, so we swap them. 7, 4, cool. 2 is less than 2 is less than 4, so we swap them. And then 2 is less than 3, these stay in place. And I'll just quickly run through all of these because this won't take very long at all. So 9 is greater than 7, we'll just swap these. If I can remember how to type, that'd be very useful. 7 is greater than 4, we'll swap these. 4 is greater than 3, we'll swap these. And you can see how this 9 and 7 pair here has kind of bubbled up from here to this position here. And the 1, 2, and 3 are now in place. Let's see here. Have the 9, we swap it with the 7. 7 and 9. And then we swap the 7 and the 4. And then finally, we swap the 9 and the 7, and these, and now our original array, which I actually don't remember the order of right now, well, now it's sorted, and you saw me sort it right in front of you. Cool. So now let's actually write that as code. So let's write this as words and then as code. For each position in the array, for each position in front of the first position, so let's actually name these positions. For each position I and for each position k, such that k is greater than I, if the value of I, so if array sub I is greater than array sub k, swap array sub I and array sub k. Cool. We've got some pseudocode written here. Let's translate that into C. We're gonna need have our array, our count. We're We're gonna need a nested set of for loops here, I think. Yeah, so we have, well, yeah, we're gonna need those nested for loops. We have the for each here. If you can describe something using using terminology like for each, you should be thinking I'm gonna be using a for loop here. So for int I equals 0, I less than count, plus I. For int k, there I should be consistent, int k equals I plus 1, k less than count, plus k. Shouldn't have those semicolons there either. So cool, now we have a nested set of for loops. You can see that in the scope of the original for loop, we can use I as part of the definition for k. And what k is will change as I changes. So now we can, most of the work is going to be done in this second for loop. In fact, all of the work is going to be done here. So we know what we need to do in this second loop. If array sub I is greater than array sub k, we're going to swap them. If array sub I greater than array sub k, how do we swap them? Well, we did it last time. Last time I broke it out into a separate function. This time I'm going to keep these 3 lines all together here. So int temp equals not number, array sub I. Array sub I equals array sub k. Array sub k equals temp. Quick recap of what this is doing. We are temporarily storing the value of I in this temp variable here. Then we load whatever is in k into the space array sub I, and then now we have 2 things that both equal array sub k. We don't need the second one anymore, so we load whatever is in temp, or what was originally in array sub I, into array sub k. Easy. And so that's that, more or less done. The one caveat with this is this algorithm is very, very slow. And you can see that. As count, if count is 10, then we have to do this 10 times, and then this loop has to run 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. If count is 1,000, this has to run 1,000 times, and this has to run roughly 1,000 times per times that this loop runs. I won't go into the technical language behind how we describe algorithms like this, but suffice to say, you can see that as count gets bigger, this algorithm gets very, very slow. So I'm actually going to ask the user to wait patiently in case they did something, in case they gave us a really big array. So printf, please wait. And then down here at the bottom, before we return from the function, printf, done. Cool. Now we have our bubble sort. Last thing we need to do is print the array to the screen. I've done something like this in the source code that I used for the lectures, and in the examples I did. So let's go through that real quick. All we need to do is run through the array one element at a time and print whatever it is, and print whatever is at the array in that location to the screen. We can do a couple of tricks with the for loop to make it look prettier. So first thing I'm going to do is printf an opening curly brace and a space, and that's all I want. Then for int I equals 0, I less than count minus 1 plus I. The reason we're doing count minus 1 here is that I have something special in mind for the last element of the array. For the last element of the array, I want to do the closing curly brace, and I don't want to have a comma after it. So, but for every other value, I can just say %d, comma, space, and pass it array sub I. And then for the last one, I want to printf %d, closing curly brace, new line character, array sub I minus, or not sub I, count -1. Because remember, there are the last index of this array, the last number that we can use in this subscript operator is count -1. Cool. One last little tweak before we compile this. I want to do a kind of before and after thing. So, printf before print array, printf after. And now let's see if this does the thing we want it to. We have gone a long time without testing this. I highly suspect my code is correct. If it's not, I'll correct the errors in front of you so you can see that process. We are in the correct directory, gcc star.c -o project5.exe. Too few arguments of the function print array. That is because I forgot to call it correctly. 6, yep, here it is. Array num elements. If that was our only problem, then we are doing pretty well. Let's run that again. Excellent. Clear the screen. Project 5. How many numbers do I want to sort? Let's start with 8. Number 1 is going to be 5, 8, 1, 3, 4, 7, 8 again, 6. Cool. And so we can see that my input formatting worked the way I wanted it to. We got the before picture of everything in the order we printed up here. Let's wait, done. Afterward, let's check our work. 1, 3, 4, 5, 6, 7, 8, 8. That looks correct to me. Cool. So, this source code will be available on the website. I will add that comment I wrote earlier that kind of demonstrates the bubble sort one step at a time below here. Kind of wrote that on the fly and then deleted it because I forgot the original order. But I'll have the comment here for you to be able to read. You should compare how we wrote this program to see what we did differently. And if you were not able to do this on your own, I hope this was informative. I hope you were able to follow along with me and understand why all of this works. Thank you for joining us, and I hope you had fun.